Solving equations using addition. We're going to solve some equations using the addition property, and we're going to keep in mind the lesson that we learned from the balance scale. I've written an equation on the board here, -8 plus b is equal to 3. In this problem, b is the unknown. This is the variable that I want to solve for. I want to find out what the quantity is that will make this equation true. I'm going to keep in mind the lesson of the balance scale. I've got the fulcrum located right here at the equal sign. So whatever I do to the left-hand side of the equation, I must also remember to do to the right-hand side of the equation. If I look at this variable, I see that I have added to it a -8. If I want it to be alone, I have to get rid of this -8. The way I'm going to get this -8 out of the left-hand side of the equation is by adding its opposite. You'll remember from learning about sign numbers that if you add a number and its opposite, you get 0. So I'm going to add 8 to the left-hand side of the equation, keeping in mind that whatever I do to the left-hand side of the equation, I must also do to the right-hand side of the equation. So I'm going to add 8 to the right-hand side as well. When I do this process, I'll notice that -8 plus 8 is equal to 0. So these cancel each other out, and I'm left only with b on the left-hand side of the equation. My equal sign will carry down. I'm going to keep that equal sign lined up. And I notice that on the right-hand side, I've got 3 plus 8 now. And 3 plus 8 is equal to 11. So it appears as if 11 is the solution to this equation. I need to check the answer to this equation and make sure that I've done my work correctly. I'm going to do this by substituting 11 in for b in the original equation. So if I come back up here, I had -8 plus b, and now my suspicion is that b is equal to 11. So I'll put 11 in for the b. I've replaced b with the 11 is equal to 3. When I add -8 to 11, I get 3, and sure enough, 3 is equal to 3. So the problem checks out. When I put the solution in that I believe to be true, I got a true equation at the bottom. So when I solved my equation, I did it by undoing the -8 by adding +8, and I remember whatever I do to the left-hand side of the equation, I must also do to the right-hand side of the equation. When I did that, I found that b was equal to 11, the solution to this problem. We're going to use our addition technique to help us solve a word problem. Let's take a look at the problem. Reliable Trucking has 9 trucks in its fleet. If Allied Trucking sold 5 of its trucks, both companies would have the same number of trucks. How many trucks does Allied Trucking have in its fleet? When you're working on a word problem, it's important to know exactly what's being asked in the problem. If we look at this last question, it says, how many trucks does Allied Trucking have in its fleet? So we're looking for how many trucks in Allied's fleet. That's the most important thing that we're trying to find. So we're going to have Allied Trucking be the unknown in this equation. We'll write up here Allied Trucking. Now we're going to compare it to Reliable Trucking. It says if Allied Trucking sold 5 of its trucks, both companies would have the same number. So we're comparing it to Reliable Trucking. We're going to put RT as our symbol for Reliable Trucking. We're comparing Allied and Reliable. Allied must have more trucks because it says if we sold 5, so if we sold 5, then they would have the same number. So selling 5 is a subtraction process. We've got Allied Trucking, and it's going to sell 5 of its trucks. We want to sell 5 of the trucks. We're going to subtract 5 in our equation. The next part says both companies would have the same number of trucks. The same number is where the equal sign goes. If I subtracted 5, they would have the same number of trucks. Now we want to convert this into an algebraic equation. I'm still looking for Allied Trucking, so I'll let Allied Trucking's fleet be represented by X. That's the unknown. That's the thing we're trying to find. We've got -5 equals the number of trucks in Reliable Trucking fleet. If we look back up here, Reliable Trucking has 9 trucks. So the number of trucks in the fleet is 9. Our equation is Allied Trucking -5 is equal to 9. Now when we solve this equation, we're going to use the addition technique. We want to make sure that we're going to add the same number to both sides of this equation. You'll remember that this equation works exactly like a balance scale with the equal sign being the fulcrum. Whatever I do to one side of the equation, I must also do to the other side of the equation. This is what I want to solve for, my unknown. I want to solve for x, and I have 5 subtracted from it. If the 5 is subtracted, I want to undo that process. I want to do the opposite thing. Since 5 is subtracted, I'm going to add 5 to both sides of the equation. If I add it to the left, I must also add it to the right. On the left-hand side of the equation, I have -5 and +5. I know that those put together are 0. They cancel each other out. So I have only x left on the left-hand side of the equation. On the right-hand side of the equation, I have 9 plus 5. That's 14. So I know that x is equal to 14. If I go back through my problem, I see that I let x be the unknown that represented the number of trucks in the Allied trucking fleet. So x is the number of trucks in the Allied trucking fleet, and I can say x is equal to 14 trucks. You want to be sure and label your answer so that you know your answer makes sense in the context of the problem. Okay, we have discovered that Allied has 14 trucks in its fleet. Let's see if it makes sense in our problem. It says if Allied Trucking sold 5 of its trucks. So if it had 14 and it sold 5, 14 minus 5, it would have 9. If I come back and look, Reliable Trucking has 9 trucks. So sure enough, both companies would have the same number of trucks. It's important when you get an answer in a problem that you check it with the problem to make sure it makes sense in the problem. We've gotten the correct answer. Allied Trucking has 14 trucks in its fleet.
This video department sold 27 TVs, and it now has 69 TVs left. How many TV sets did they originally have? This is a simple math problem that I know you can solve in your head, but I want to use this problem to demonstrate solving equations by using addition. So the video department has 69 TVs, and they sold 27 TVs. And the question is, how many TVs did they originally have? So this is the unknown then. And we're going to make this unknown x. And x stands for how many TVs did they originally have. So the original number of TVs is x. Now, out of that x, they sold, and that means minus. They sold, this is negative, they sold 27 TVs. So it's minus 27. So what they started with, the number of TVs here, which is unknown, they sold 27, and now the video department has 69 TVs. So this unknown, you take away the 27, equals 69. Now we're going to add 27 here, and remember, on that scale, whatever you do on the one side, you must do on the other side. Now we come over here and do 27. And this is what we want to show you, and that's why we use a simple problem to show you solving equations by using addition. And this cancels out. Now we add these two amounts together. 9 plus 7 is 16, plus 1. 1 plus 6 is 7, plus 2 is 9. So x equals 96 TVs. And so you can see that though it's a simple problem, it helps you to understand how to solve equations by using addition. Now let's just go back here and use this unknown here, this x minus 27 equals 69. And let's put in 96 for the x. 96 minus 27 equals 69. And so it's 96 minus 27. And we borrow here, that would be 9. And this would be 69 equals 69. So you know that we did the problem properly.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.